Okay, so let's dive right into the first part of this problem. The first question that is asked is why do we see extra copper appearing on the outside of the copper cathode? This is fairly simple and should be familiar to anyone who's in this unit of AP chemistry. As a galvanic cell functions, electrons flow from the anode to the cathode, flow this way, which means that zinc atoms in the anode are going to be oxidized into zinc 2 plus atoms that are going to go into the solution, and meanwhile copper 2 plus ions in the solution are going to be reduced and are going to tack on as solid copper atoms to the edge of the copper cathode, because that's where the reduction is going to be happening, because the copper cathode is going to have the extra electrons used for reduction. Okay, so that's the simple part of this problem over. Now we have the unusual thing that we wouldn't expect, and that's that we're seeing a change in mass of these whole sides, of this whole section right here. Now, this is unusual because we usually don't see this change in mass. So what makes this galvanic cell so special? Well, the thing about this galvanic cell is that it's massive, right? The extra mass of copper we see after a few days is 127 kilograms, whereas normally it would be on the level of like micrograms or milligrams. Maybe with a particularly large one we'd see a few grams, but here we're seeing hundreds of kilograms. So it's a very, very, very large galvanic cell. And so now we can think, well, what's entering the copper cell from the zinc cell? And we can see pretty quickly the only thing going between them is the electrons. And in chemistry, we usually think of electrons as being effectively massless, but that's not really true. And if you do a Google search, you can find that electrons actually have a molar mass of, it's about 0.000549 grams per mole. Which is very, very small. I mean, the molar mass of hydrogen is 1 gram per mole, which is about 2,000 times bigger than this. But it is non-negligible, especially with these really large numbers. So that might explain our slight change in mass, and let's do the math. The first step here is we need to figure out how many electrons are going from the anode to the cathode. And in order to do this, we need to think about the mass of extra copper, because every mole of copper that is present on the outside of this cathode is 2 electrons that have gone from this anode to the cathode, because we have copper 2 plus. So let's calculate our moles of copper on the outside. This is very simple. You can look up the molar mass of copper. It's 63.55 grams per mole. And so we just divide 127,100 grams, converting from kilograms to grams, over 63.55 grams per mole. And this nets us 2,000 moles of copper being reduced from the solution, of copper 2 plus being reduced from the solution. Now we multiply this by 2 to get the number 2,000 to get the number of electrons that move from the anode to the cathode, because it's 2 electrons per atom, and that obviously gives us 4,000 moles of electrons. Okay, so our last step is to multiply this by the molar mass we have here. So we have 4,000 moles electrons times 0.000549 grams per mole electrons. And you can do the math yourself. This ends up being about 2.2 grams. Which, isn't the most significant thing when we're dealing with scales of 127 kilograms, but this definitely would show up on a lot of scales. 2.2 grams is a lot more significant than the milligrams we would usually see with the galvanic cells that we deal with in most settings.